Looks like we're live. Hello everyone and welcome to yet another recreational programming session. How about that? I bet you didn't expect that to happen yet again. So let's make a little bit of an announcement and officially start the stream. So let me bring up my Discord server, right? And let's do a red circle. Live on Twitch. And what are we doing today on Twitch? We are making programming language as usual, right? So I'm gonna give the link to the Twitch channel, twitch.tv/Tsogin, and I'm gonna ping everyone who's interested in being pinged as usual. So yeah, as I already mentioned, we are making our own programming language. The language is called Porth. It's a concatenative programming language, kind of like similar to Forth, and we just keep developing this thing. You can find the source code in the description, right? If you're watching on YouTube or if you're watching live, you can do the project command and the bot will going to give you the link. Hello everyone, welcome. Really glad to see you all today. So in the programming language, we have a keyword called include, right? So if I open porth.porth, so you'll see that it has include, and essentially what it does, it takes the file that you provided in here and it includes that file, like all of the tokens of that file, into this file. Not really includes, it actually starts translating this file, right? And then once it's finished translating and compiling this specific file, it will continue translating the rest of the file. It does not really include anything, it's just like yeah, it's just like continues the process inside of this file, but you can treat it as include. And because of that, it suffers from the same problem as the C preprocessor, right? So in the C preprocessor, you have include keyword, and it also includes the entire thing. And that problem is that double include. Right, so it's quite easy when you have like a graph of like different files depending on each other to actually include the same file twice, and that means all of the definitions in that file will be included twice and they will conflict with each other. So in C, usually people do something like include guards with if defs and defines and stuff like that, or there is an extension for C programming language, C and C++ programming language, you do pragma once, right? In any case, it's basically to prevent the including the file twice. You know what's interesting is that we could try to do something like that, right? We can try to make it like optional, so whether you want to include file twice or you don't want to include file twice. But from my experience, in 99.9999999999999% of the cases, you don't want to include the file twice. And in 0.0000001% of the case, it's usually some weird library like Boost that suggests including some files, some template files in the bodies of your functions. And I don't really want to go into that territory. Like let's let Boost be Boost and let's do our own thing. So I think since this is the primary thing that you want to do, right? So usually if you include file, you almost always don't want to include it twice. Let's make this a default behavior. Let's make it so the include, when you include the file, it doesn't include it twice, right? So if the file was already included at some point, it's going to be ignored. So sounds good. And by the way, just a quick disclaimer. This is not the final way how the module system will work, right? So the entire include system is just some sort of like a hack to get us going, right? So yeah, and I implemented it only temporarily. Like in the future, we're gonna have like a little bit more advanced module system, but for now we're gonna have includes, and today we're gonna implement so that you cannot include twice. Sounds good? Sounds Gucci? Sounds a Tamaguchi. Valini, thank you so much for 8-month-old Twitch Prime subscription. Thank you, and welcome to our epic Porth Club. How about that? Cheers, by the way. So let's go ahead and do that. So here's the source code, and where do we include files, right? So we have a keyword include. So let's try to find that keyword. So here we're translating a string to a keyword. Here we're translating keyword to a string. And in here, I think we're parsing essentially. So if I take a look at the procedure where all of that starts, so this is a compile file into operations. And then we take the token string, then we check the include limit, and then we're trying to include the files from different sort of bases, right? So you provided the file that you want to include. We try to search for that file within the current folder. If it doesn't exist, we're trying to search for it in std folder, in the current folder as well. And if it doesn't exist, we're trying to search for it. This one is interesting. We're trying to search for it in the same folder this file in. So you're currently compiling this file, and we're looking for the included file with the same folder. Which is interesting. So basically, we're checking these three cases, and I just realized how we're gonna be like detecting that you already included the same file if we also have relative paths. You know what I mean? What if you include the same file but from different relative paths? How can you like distinguish between those files? I guess first thing that you'll have to do before including the file, you'll have to essentially maybe expand that file into full path, and we can use the full path as the sort of ID for that file. So this is the first problem, right? So this is going to be the first problem that we need to solve, like how do we know that we already included that file because of the relative path and stuff like that. And the second problem is that how do we avoid the circular inclusion, right? So what if we are including the same file already, and we kind of want to warn the user about that, but here we have an include limit, right? So right now we're handling that by not allowing to include too many times. But it's not ideal, right? We want to actually detect the cycles, detect the loops. So I think we'll need to solve that in this specific case. So the way I usually solve these kind of problems, right? So I already solved that problem before. I'm going to actually solve it again. We're going to have a structure that holds the included files, right? So I don't know how exactly we're going to call that structure. Maybe let's call it module. I don't know. Maybe because in the future it's going to evolve into a module system. So let's just call it module. This is going to be a structure module. And what fields are we going to have in the module? We're going to have a module path, and this is going to be actually full path. So let's actually call it full path. So it's going to be a string. So that means it's going to be size of str offset. Right. And another thing is the status of the module. So this is where sort of like a loop prevention mechanism will kick in. So module status, size of str offset. Not sure what kind of like, it's actually not string, it has to be an integer. So there will be two statuses for the module, right? There will be two statuses for the module. The first status is going to be module status included, or maybe finished, so something like that. So the status is finished. That means the module was fully processed and it's already included and no processing is required. And another status is going to be probably something like in progress, right? In progress offset. So module status. And essentially when we start compiling the file, right, we add it to the list of modules that we're currently working with, and we set its status to in progress. Right, and then if during the compilation we trying to include a file again that is in progress, we know that we detected a loop, and this is where we can throw an exception or some sort of error. Since there could be only two statuses in here, maybe it doesn't make any sense to introduce enumeration right now. So maybe I'm gonna do something like in progress, right? So this is gonna be in progress, and this one is gonna be Boolean, or maybe. So to make it in progress by default, we can make it finished, right? So essentially, if you allocate the structure module and 0 initialize it, finished is going to be false, meaning that it's in progress. And once you finish doing things with the module, you will set it to true and it will become finished. So something like that. Nihlete, I hope I pronounced your nickname correctly. Thank you so much for tier 1 subscription. Thank you, thank you, thank you. Your first subscription, by the way, and welcome to our Epic Port Club. So yeah, and as I already said, we need to have like a global list of modules. Every time we need a global list of modules, we need to define the capacity. So let's define modules capacity, and how many modules do you want to include? Maybe like, 1,000 of them should be enough for everyone. In the future, like I have a lot of fixed arrays, but in the future I'm going to replace them with dynamic arrays. So it's only temporary. It is only temporary, my friends. Cheers, by the way. Okay, so we're gonna have memory modules, size of a single module multiplied by the module's capacity. All right, and we also are gonna have something like modules count, and this is basically how many modules we already have defined. And we also need some function that looks up the module, right? So before including the module, we're going to be looking it up just to find out whether it was already included or not, and then make a decision on, on whether to throw an error or to simply ignore it. Coffee Before Code, thank you so much for 2 months of tier 1 subscription. Hello, 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 thank you so much, and welcome back to our Epic Port Club. Just a second. Thank you for all of the subscriptions. So module lookup, and we're going to provide the name, and here we're going to return, I suppose, the pointer to the module structure. I think that makes sense. Right, so this one is going to be drop. Might as well actually do something like, I don't know, drop. And in here I'm going to just return null for now, and then I'm going to say that module lookup is not implemented. Is not implemented yet. Something like this. So this is where we start compiling the file, right? By the way, we compiling the file that is a C string. And the reason why it is a C string is because the open function, right, it accepts C strings, not the size strings. So maybe because of that, full path has to be a C string, meaning that it has to be a size of pointer. And because of that, we probably want to actually accept this kind of thing. So this is going to be full path, right? So some sort of full path C string. So, and in here, do we expect a full path or not full path? Let's actually not think too much about full paths and not full paths. I don't think they matter that much. So include level, since we're going to be like having a detection include level, basically loop detection mechanism, I don't think we need include level anymore. So I kind of want to refactor it, basically factor it out and completely remove it. So before I can do that, I think I'm going to recompile the entire language just to see how it's going. Right, so we want to be a little bit careful. Not enough arguments for the drop, so that's fair enough. Interestingly enough, like we accept the pointer, return the pointer, so maybe I don't even have to drop anything in here. I can just like, recompile the whole thing. And that's going to be the fine. So also let me create a separate branch. So include once, right? So we're going to have include once. And let's commit the entire thing. Introduce module structure. Right, there we go. So, and let's start factoring out the include level. So I'm going to remove that, and I'm going to remove that, and I'm going to follow the compilation errors because I'm using statically typed compiled language. Right. So in here, if we reach the include level, include limit, we're going to throw an error, but we don't have to do that anymore because we don't have include level. And in here, we are essentially incrementing the entire thing and compile it again. We also don't have to do that anymore. Okay, so here I set it to 0. It doesn't matter. All right. And everything seems to be working. So I managed to remove the include level, which is nice. So because of that, include limit also doesn't make any sense. So include limit. Let's go ahead and remove that as well. Okay. remove include limit. Do I want to say anything else? With the loop detection mechanism based on module finished, we won't need this anymore. I would even say this hack, because it's definitely a hack, and I'm gonna push that right into the repo. Okay. So the next thing is I probably want to look up that name in the modules. So here's a good opportunity to try to use the LED bindings, right? How do I use file path sister? I don't think I'm using it, like I don't think I'm modifying it at all. So that means I can simply let bind it, and let me take a look at this stuff. So this is proc, this is mine. Okay, so that's fine. So it means I can do something like let file path sister, right? And I'm gonna put it like this, and let me find end. So here's the end, and in here I'm gonna just put it like that, right? I'm gonna just put it like that, and in all of the places where I access file path sister, I think I need to replace it with just a regular access, right? So in the bindings you don't have to dereference this entire thing. All right, but I'm not sure about that one, because that one is part of the main. Okay, so if I try to recompile the entire thing should kind of work, hopefully. We'll see. All right. Seems to be working. Seems to be working. Okay, cool. So this was file path compile. Oops. Compile file into oops. All right. So, and here is the interesting part. Here is the interesting part. I wanna use that file to look up the specific module, right? So I can do module lookup, and that thing should give me the module, right? So I can actually do dupe. And how we're gonna do that? If we never encountered that module before, this thing will return null. So there's like several situations in here. The first one, this thing is null. That means we never encountered that before. So we have to do something in here. Otherwise, it is not null. What we can do now, we can check whether it's finished or not, right? So this is going to be ptr plus, and we're going to read it as a boolean. Is it finished or not? So this is going to be another thing. Including the module first time. Then in here, we're going to do the module was already included. Right, the module was already included. And the last thing is when it's in progress, right? It's not finished. Detected loop, right? So essentially, if you try to include a module that is not finished yet, that means you basically detected a loop. The reason why it is like that, it's actually very interesting. So let's imagine that we have like a graph of files. I'm really sorry that the wire like touches the microphone stand. So let me see. Right, so we have sort of like this dependency graphs, a graph of files. Right, so this file depends on this file depends on this file, and this file depends on this file. Right, so you start compiling this file and you mark it as not finished. So dot will basically mean not finished. Then you mark this as not finished because you're compiling it. Then you mark it as not finished and not finished. Then you finish that file. Then you like sort of go back in recursion and mark it as finished, and then you mark it as finished, and then you mark it as finished. But what if you have some sort of like a loop, right? So what happens when you have a loop? let's put it like this, and let's put another file in here, like so. So you try to include that one, you compile in this one, compile in this one, compile in this one, and you need to compile this one, but you detected that it was already included. So you basically throw an error in here, right? So that's why I want to do that. So that's why it works. That's why it works. So by just basically marking whether something is finished or not. Does it make sense? I hope it makes sense. Okay. So yeah, it's just like a graph algorithms and stuff. And this one is rather interesting because if something is finished, we want to basically short circuit from the procedure, but Porter doesn't really support short circuiting from the procedures yet. So, which leads me to an interesting rather questions. How are we gonna even do that? So we can basically include the entire thing into that stuff. All right, including the module first time. If we are including the module first time, we want to add that module to the module list, right? So let's put it this way: module start, right? Module start, we're gonna accept the full path, right? So this is a full path sister, and I suppose it will return the pointer to the module structure that it just like included there, which we can then use to mark that module as finished at the end, right? So that's going to be the idea essentially. But in here I'm going to just say this thing is not implemented yet. Module start is not implemented yet. All right, so okay. So this is the module lookup. We didn't find that thing, but in here we also kind of duplicated it. Which I'm not sure whether it's a good idea or not. I'm not really sure if it's a good idea or not, but maybe it doesn't really matter. So file path sister, and I want to do module start, right? So this is going to be module start, and it will return the pointer. And I want to kind of retain the entire thing and just like continue working. Ah, man, but I also need to drop whatever we got from this thing. So, and the most unpleasant thing about that is that I have to literally take the entire body in here and sort of like move it inside of here, because again, Port does not support short circuiting from the procedure, right? Basically early return yet. It doesn't support that yet, so maybe in the future we're going to support that. I haven't decided yet. Another thing we can do in here, we can probably move that stuff into separate function, but that means I'll need mutual recursion, which Port also doesn't support. Right. So, and I can't decide what exactly do I want to do here. Do I really want to go the route of like moving this entire thing in there? It's a very good question. We can try, but it's not going to be particularly pleasant. Okay. So let's just go ahead and do that, I suppose. Let's just go ahead and do that. I can't really decide what would be the best way to do that. So here we're looking up. Okay, let me put a little bit of space in here so I can at least visually separate all of that. All right. I think it should go without, you know, saying, but I'm gonna say it again. The language is not finished, okay? So I'm in the middle of making the language, I'm in the middle of designing the language. Of course, the final experience with the language is not going to be like that. The reason why I'm struggling right now is because I'm trying to figure out what's needed for the language, right? So the language needs, you know, time and work to actually, you know, appear at all in the world. Right, so I'm going to take this thing and just put it like that. Okay, so we do file path, we just do it like this, and this is where I'm gonna include the entire thing. So here is the to-do. Some of this stuff could have been actually easily compressed by moving it sort of like inside of the separate procedures. Some of the things that some of these branches could be moved into separate procedures. And I already did some stuff for while keywords, I think, something like enclose, but not specifically here, so that should be fine. Okay, so compile file, and then proc compile file. Okay, finally found it. All right, so let's go in here and so we need to find the to-do. I remember seeing that to-do in there, so maybe I'm gonna actually speed it up a little bit so it's somewhere. Here it is. Yeah. Yeah, something like this. Cool. All right. So that was actually necessary. That was actually necessary, believe it or not. I hope that is not gonna cause like a very severe compilation error. We'll see. We'll see. So this is module path, and then I'll have to essentially close that stuff, right? So I'll need to find 1, 2, 3, 4 else. Oh yeah, that is not particularly convenient. So let's find it 1, 2, 3, 4 else, and it's not there for whatever reason, but I'm not really sure. So where is that opposite part? So let me find and okay. Even though I said why it couldn't find that 1, 2, 3, 4 else, and here it is. Here it can actually find that. So okay, anyway, here it should have only one pointer, which is the structure that we actually moved from there. Procedure definition is not allowed, so that means I forgot to close something within there. So I forgot to close the structure. Oh, I see what's going on. So I need to else, yeah. So this is precisely what's going on here. Okay, so here it's pointer equal. Perfect. Okay, so and that's the pointer, and that pointer is located here. Okay, so this is exactly what I expected in here. This is exactly what I expected. Cool. So and that pointer is the pointer to the module. So I can now do something like module finished, right? Finished pointer plus, and essentially now I can save true to that. But what's going to be the easiest way to do that? So you can do a very hacky thing. Actually, you can put boolean, I think, in front of this entire thing, like true in front of this entire thing, and then set that true in here. But that's a very scammy move, because the value that you can technically do that, but it's really, really scammy. Anyway, so here is the boolean that you're trying to set, and here is another thing. So Yesu. And I'm not sure. So I think I'm gonna just like swap it around. Right, I'm gonna swap it around. So we do plus, and then you do boolean swap, and you just set that boolean, and that should be it. And that entire thing should kind of compile. Right, it should kind of compile, but then we have unhandled pointer in here, which is okay. So that makes sense. That means we'll have to drop that pointer. Right, we'll have to drop that pointer. Okay, so it seems to be compiling. And if I try to recompile it again, I wonder if I busted the compiler. Okay, so yeah, I didn't really bust the compiler, but now it works as intended. So before trying to compile, it looks up the module that it's trying to compile. All right. So let me now think. How are we going to implement all of that? So I think I'm not going to support the full paths right now. I'm going to just implement the system that uses the user provided path as the IDs. And once we get that working, right, we can try to implement like a system that actually expands the full path before including them and before adding them to the module lookup system, right? So that's basically what we can do. All right, so let's implement lookup. Lookup is essentially going to be like a linear lookup in the array of modules. But again, it is slow. I do know that it is slow. I just don't care about it right now. I'm trying to implement the feature. So, okay. So we need to do something like while dupe modules count. And I'm going to read that. And I'm going to iterate through this entire thing. While plus. Okay, so then I'm going to take the index size of module, right? I'm going to multiply this thing, size of module, and then I'll need to add it to the array of modules. So it's going to be plus pointer. Then I want to probably take the entire thing. Oh, yet again, so we'll need to early exit from this entire thing. That means I'll have to put this thing in here, right? So while it's less, I'm going to do it like that. Otherwise, it is going to be false. All right. So then I take the index, I turn it into a module. And for that specific module, what I want to do. What I want to do, so maybe I'm gonna just like use it like that. So here is the module, then module full path, right? So this is a full path. Module full path pointer plus, and then I probably need to read it as a single pointer, right? I'm trying to read it as a single pointer. And here's the full path, by the way, so which we also need to get, right? So path, let's call it path sister, right? So this is a path sister, and this is going to be end. This is going to be end. Okay, so this is the module, shall count modules. Full path, and I'm gonna take the path sister and I want to compare them. So for that I have C sister equals, and if they are equal, we're gonna continue doing that. So essentially I want to continue iterating while they're not equal, so I'll have to put L not in here, which does make sense, hopefully. So here I duplicate the index. Right, but here I also consume the module, so that should be fine actually. I think that should be fine. And in here now, what I want to do, I want to check if the index is I'm just thinking what would be the most elegant way of doing that, right? So what would be the most elegant? So obviously, like here we have an index, and what we can do, we can just compare that index to the full path. So if modules count integer is less, right? That means we found something. That means we found something, and we can essentially just return that thing in here. Otherwise, we'll have to return null, right? And that should be it. Okay, so here we take in the path, then we iterating. While we iterating, we check in everything, right? So we're checking if it's a equal full path, and then if it's less, we do that. If it's greater, that means we actually went through the entire thing and we didn't find anything. Right, so let me try to compile that, but I can't compile that because I busted the compiler, so we'll have to use the Bootstrap Compiler port, and let me see if it's gonna compile. So it seems to be all right, not enough. But got one. All right, that's very interesting. Oh, okay, I see. So because you need to duplicate it, so this operation sort of consumed the index, but now I have to actually take it. Okay, that makes sense. Sure. Unhandled data on the stack. So why do you say unhandled data? Oh my god, Emacs. So integer, and where is that integer coming from? Oh, I see. So that means here I'll have to drop that. But honestly, I can always just like make something like this. Let index. Right, and just use this index, and then drop, and then just end it in here. All right. Just end it in here, and that looks fine. That looks fine. So do I want to also like add an index in there? Probably not. So probably gonna keep it like that. All right. So I like how compilation gets slower and slower. I really like that. So at some point I'll probably have to do something about that. But apparently the compiler can compile. And now can the resulting compiler compile itself? So I can't really get that thing. Module start is not... Okay, so it does not complain about this thing anymore, but it does complain about module start. So that's quite interesting. Path str, right, so we'll have to do it like that. So this is the path str. And in here, I suppose we'll have to probably first check that we don't overflow the list of modules, right? We don't overflow the list of modules. That's quite important, I think. So it's going to be modules count, and I'm going to read this entire thing, and I want to make sure that we don't overflow module capacity, right? So it has to be, if it's greater or equal, that means we'll have to throw an assertion error, right? It puts assertion failed, modules overflow, right? So this is a modules overflow, and then I'm gonna just like exit like so. So this is gonna be path, and that means in here we'll have to add a new module. So I take the modules count int, I then multiply by the size of the modules, right? So I multiply by size, then I take the modules plus pointer, and then I do let module. So probably I want to zero initialize the module into which I'm inserting everything, or maybe not actually. So I can do, because I'm going to setting up the fields anyway, so I can just do path sister module full path pointer plus, and I'm just saving that pointer in there. So then I can say false module finished pointer plus pointer. So, and we can even align this kind of stuff like so, right? So we just initialize the module, right? And now we have to also return that module, right? So, and in here it would be nice to have something like peak, right? But we only have flat. So I take that and I initialize everything, and I just return the entire stuff, and that should be it actually. That should be it. Okay. So, and let's try to recompile the compiler. Right, so it does not compile properly. Argument is not a pointer. Excuse me. Oh, because it's a boolean. Okay, that's right. All right, so the compilation got faster, which is funny. Sometimes like the performance fluctuates for whatever reason, but I don't really go into the analyzing the performance right now because I don't really care about it right now. Okay, so I can recompile the compiler, but can the resulting compiler recompile itself? Apparently it can. And it can recompile itself several times. Okay, so essentially we got rid of the include limit and we put the module system, like the module tracking system, on top of the entire thing. Right, and I didn't break anything, which is quite surprising. I was expecting that I'm gonna break something pretty badly, but I didn't. So that's actually pretty cool. Really glad. So because like I had to copy paste this entire stuff, and the port does not support a lot of things. Because the language is not finished, right? I know it's crazy, the language is in intermediate state, and it's not like magically appeared out of nowhere like the languages usually do, right, but yeah. Okay, so after the compilation, I want to try something interesting. Let's actually go in here and print all of the modules that we included. How about that? I think that's interesting. Right, so I'm gonna just essentially do 0, duplicate, and then modules account. I'm gonna read that, and then while it's less and plus. So here we have an index, right, in here. Then I take that index, I multiply that by the size of the module, then I take modules plus pointer. This is the new module I'm working with, and in here I can just like, you know, do module, module full path, and I want to convert it to a string, sister to str, right, and then I want to print it, so it's going to be puts, and then I'm going to print new line. So, and this entire approach, in fact, makes it super easy to factor it out without the let bindings. So essentially, if we have this kind of situation, I can probably factor it out to something like this, right? So I can just do something like that. But in here, I can factor it out to do something like this, right? So, okay, so you can... This is actually quite fascinating. So you can use let bindings as sort of like a helper to write initial code, and then you can compress that code into like a fourth style code, right? So yeah, let binding can actually help you to like then compress it into more unreadable version of the code. Yeah, because here like I have a fourth style code, but I didn't have to think about it too much because I used let binding. So, but we don't know if this compiles or not. So it probably doesn't because I have to do pointer plus in here. Right. So here I duplicate the index, I multiply by the index by the size, then I offset the module, then I offset to find the full path, then I convert it, and then I print it. So yeah. That's quite interesting actually. Okay. So we have unhandled data on the stack, and that unhandled data is in here because I forgot to drop it. So we might as well, you know, do something like this. Included modules, right? So info, let's say compiled modules, new line. So this is a new line, and then I'm gonna do puts. There we go. Then we're going to do puts. Okay, so if I try to recompile the entire thing, is it gonna tell me compiled modules? I think it did, but in fact it didn't print anything, which is kind of sus, isn't it? Huh. It really didn't print anything. Compiled. Let's put it this way. So this is going to be puts. This is another puts, and then we can try to say, oh, I know what's going on. Yeah, put you. Okay. Put you. So it will probably say 0 modules. It will probably say 0 modules. Well, we have to recompile it one more time. Yeah, it says compiled 0 modules. It never actually compiled any module. And this is because when I do modules start, I forgot, like, what was that? Module start. Yeah, module start. I forgot to increment the counter, right? So I forgot a very important thing in here. So let me try to do that. So modules count inc64. So that should work now. So that should actually work. But the first time it's not going to say anything, but now it should say, yeah, I compiled 2 modules and the, you know, the SCP garbage. I really like that. Skifry, I hope I'm pronouncing the name correctly. Thank you so much for tier 1 subscription. Thank you, thank you, thank you. And welcome to our Epic Port Club. I really appreciate all of the subscriptions. Thank you, thank you, thank you. I buy coffee and tea on all of the Twitch money I get. All right. So let me see what the hell has happened in here, because that's kind of sus, not gonna lie. So I take this thing, right, and I just do full path, and that's really, really sus. So I do module start. When I do module start, by the way, let me do a little bit of a logging, right? Debug started, and it's gonna be puts. So maybe it would make sense to actually do that in here because I have an access to path to str. So this is gonna be something like that. Path sister, sister to str. And the puts, and then we will have to put some stuff in here. Let's align puts. So, and in the second run, started that. Okay, so that works fine. Right, as you can see, we managed to start all of these modules, right, that we're doing. But then, as we go to the compiled, it says that it can't really understand that. Can you declare local memories inside late bindings? Yes, you can. In fact, it doesn't really matter where you define them because local memories are not scoped. Right. So they're kind of like logically hoisted to the beginning of the procedure anyway. Right. So yeah, it doesn't matter. In fact, you can't define several local modules. So let me actually show you how it works. Where is my stuff? So the return stack. How does a return stack look like? How does a return stack look like? So here's the return stack. When you call a procedure here, you have a return address, right? So here's your return address. Then you have local memories. So this is the local memories. And all of the local memories are going to go after the return address, no matter where you define them within the function. They're always going to go right after the return address. And bindings go after the local memories, right? So this is where the bindings live. So this is how the stack is laid out right now. It is right now because the language is not finished, right? So by the way, everything I say about how the language works is right now. And it may change in the future. And it will probably change in the future because the language is not finished. Please keep that in mind every time I say anything about this language. Syntax may change, semantics may change, implementation may change, how we generate assembly code may change, everything may change. It's in the middle of the design process. Right, so do not assume that that's the final language. Do not assume that. So right now, return address, local variables, regardless of where they're defined, bindings. So that's how it works right now. Make sense? I could not stress that enough because people like look at this language and they assume this is the final language, this is how it's going to be. And I kind of understand that because people quite rarely do this kind of thing, right? Because quite often the languages are developed in complete secret, right? by some huge companies or stuff like that, and then they're revealed to the public, like being ready to use and stuff like that, right? So like people quite rarely see languages in their intermediate states, right? So I think maybe today it's not particularly true with open source and stuff like that. What's funny is that Rust is one of those languages that people actually saw in its intermediate state being unfinished, but nobody actually minded that. Everyone actually loved that, right? People were super happy to use completely unfinished language for a very long time until Rust became stable. It's just like very strange phenomenon. And anyway, so anyways, so here's the module lookup. So what are we doing? We need to understand what the hell is going on. Compile program into this thing. So we are... Oh, I forgot to read that from the structure. Okay, that makes sense. PTR. So I need to read that thing as well. Alrighty, so that should work. So it will garbage for a while. And then, yeah, so this is the modules that we managed to compile. That's pretty powerful, isn't it? So maybe we can have some sort of like a dummy example, right? Let's actually try to do that. Can we have a dummy example? So this is going to be foo port. And in foo port, we're going to define... oh, this one is interesting. So we can include std now. So we're including std. Right, and then I'm going to define proc foo. And in here, we're going to just say foo puts. So this is foo. This is module foo. The next module we're going to create module bar. So I think I did a fucky-wacky, bar.port. And this module also going to include std port. You see? So something interesting is going on. So we have foo, and here we're going to have bar. Proc in bar puts. Cool. So, and I think we also want to create some sort of a main program, which includes both of them. So foo port, bar port, but this entire thing has main entry point, like so. So this is going to be foo, and this is going to be bar. You see what's going on, right? So we can even draw out the like sort of structure of this entire stuff. Because it basically creates a diamond, right? So diamond problem, the famous C++ diamond problem, but it's about inheritance. It's not really about like include like dependencies or anything like that. So we have std. Don't clip that out of the context, please. So we have std, then we have foo, and we have bar, and then we have main, right? So that's basically what's going on. Foo includes std, and bar includes std as well, and main includes both of these things. So in the original sort of situation, like in the original compiler, this setup should not compile at all, right? Because you include std once, and then through bar you would include std twice, and this is why in C and C++ you have like some sort of like a you know, inclusion guards, so we don't do that. Are circular references taken care of? What do you think we're doing right now? Anyways, yeah, let's actually try to compile that with the old language, with the old compiler, and see how it fails. All right, so unknown subcommand. Okay, so I have to do something like com. Okay, redefinition of constant null. Yeah, there we go. So that's precisely what I was talking about. Redefinition of constant null is defined in here, but the original isn't here. And the reason why it complains is because, you know, it was included twice. Right, so now I'm going to try to do that with the new compiler, and let's just see what's going to happen. Module was already included, but that's to do. Look at that. Oh, we can even see how they were included. So we get main, foo, then std port, then bar. So as you can see, we're doing DFS, we're actually doing DFS. And then the module was already included, and this is to do. And that's what's interesting about this entire thing. Right, I think in case of the included module, we just don't have to do anything. And that means we can compress these two branches into something like L naught. Right, so L naught. Yes, so basically you have two situations, whether the module was never included before, in that case we're including it, we're compiling it, or it was included before, but it's not, but it's finished. In that case we just fall through and we never try to include it. But it was, if it was not finished, we detected a loop. All right, so let's try to recompile the compiler. And handle data on the stack. This one is interesting. So it's that one. Ooh. So it's that one, but I thought I actually dropped it, didn't I? Let me go back to how this entire thing was working. Oh shit. So detected loop. So why drop didn't work? Why just dropping didn't work? I'm not quite sure. Ah, yeah, I know. Okay, so you know what? I'm gonna just like ignoring already included module. So I kind of want to keep this branch because it makes it like the logic a little bit more explicit, right? So this is the, yeah, I just basically want to explore all of the possible control flows. That's why I'm going to keep it like that. And yeah, here I'll have to drop it. Here I'll have to drop it. Okay, so we compiled everything, and now if I try to compile the main thing, it compiled. Look at that. We compiled 4 modules: main, foo, bar, and we only included 4. So we take it, we basically handled this specific case, and it works. With the old compiler, that wouldn't work. With the old compiler, that doesn't work because you have a definition. With the new compiler that we just developed in here, it does take care of the diamond inclusion situation. So you basically can have 2 files that include the std port, and it will not include twice. But it doesn't take, basically, it doesn't expand the path to the full paths. So you can kind of trick the entire thing. You can quite easily trick the entire thing, so which is a problem. But we can put it to do in there and just like fix it later. But yeah, for now it works. So, and the second situation is circular inclusion, right? So let's actually craft a thing that, you know, performs a circular inclusion. So we have foo bar, and let's define another one, which is going to be buzz. So this is going to be port, and the buzz is probably gonna be, I don't know, how do I want to do that? I want to include, let's include foo, proc, buzz in, and in here, since I'm going to be depending on the standard library, include std port, right, I'm including std port, and then buzz, new line, eputs. Right, so this is going to be buzz. We include in foo. In foo, I think we should include bar. We should include bar. And in bar, we should include buzz. And in buzz, as you can see, we include in foo. Right. So I think that's basically what we have in here, and we can actually include all of them in here too. So let's try to update the current situation. So we have std, okay. Foo. So I think we're gonna do something like that. Foo bar buzz and then main. Right, so this is kind of the new situation. So let me take a look. Foo includes std, right? It includes std and it includes bar, right? So that's what we have. Then in bar we include std and we include buzz. In buzz we include std, so that means we go here, and we also include foo, right? So this is what we're doing here. So we already have a loop in here, as you can see, right? So this is the loop, and main includes all of them, which does not necessarily create a loop. I don't think it creates like a loop in here, but there's only one loop, which is between foo, bar, and buzz, right? So here they're just looping through each other. So, and our compiler should be able to detect this kind of situation. So let's see, detected loop, right? So it managed to detect a loop and actually mutual recursive loop, right? So we did not directly include one file into itself. We actually like included chain of 3 files, and we still detected that, right? And this is due to marking, you know, including modules as not finished, right? So you're trying to include a module that is not finished yet. That means you're detected a loop. Right. So as you can see here, we started main, then foo, then std port, then bar. We didn't start, you know, we didn't start main. We didn't start std because it was already included. Though we can actually do something interesting. If we don't, if we need to ignore this entire thing, we can at least say that. So this one is going to be something like debug, ignoring, actually not inputs, but just puts. So let file, yeah, it's a file path pointer of systr, systr to str, puts, and then new line, and then puts yet again, and then I'm gonna align puts like this. So yeah, I'm gonna just keep it like that. Yeah. So let's recompile the compiler. Let's recompile the compiler, and I'm gonna try to recompile main again. Okay, so as you can see, started main, started foo, started this one, ignoring std port because it was already included, starting buzz, ignoring that, but here, detected a loop. Okay, so I wonder what we can do now. Right. What we can do now? How can we report that? It would be nice to actually tell that detected a loop while including certain file, but I don't think we have location to report about. At least I don't think so. At least I don't think so. Unless we store the location within the source code in the module itself, but I don't think it's a good idea generally. So I don't even know. It would be kind of nice to like report the whole chain. It would be kind of nice to report the whole chain, but how can we report the whole chain? So I already said multiple times that the full path support, like detecting different paths, is going to be implemented later because I don't want to focus on that right now. I said that explicitly multiple times, and some people are incapable to comprehend that. I have no idea why. So, and it's very, very sad. It is very, very sad. Alrighty. So I think I want to maybe make a small break and refill my cup of water. And then we're gonna continue. So because I still need to think how I'm gonna be reporting the detected loop. One of the things I'm thinking about actually is maybe store like the previous module in here, like from which module, from which file it was included. Maybe, not sure if it's possible somehow. Yeah. So essentially I need to be able to restore the whole chain so I can print that whole chain. Right. So, and maybe I can do something like previous path, right, size of pointer. Or maybe previous... But you can have actually several previous files, right? So it does not necessarily manifest the loop, right? Does not necessarily manifest the loop. So yeah, maybe I'm gonna just have a very crappy error reporting on the detected loop, and then I'm gonna just put to do and fix that later. Stack of parents. Stack of parents doesn't sound that bad actually. Yeah. Yeah, so basically we can just like maintain the stack and then report off of that stack. It's not a bad idea actually, thank you. But anyway, so let's make a small break and all right, so let's actually try to properly like you know, not detect but report the loop detection error. Loop detected. Okay. So what we're gonna say in here? We could probably organize the stack or something like that, but I really don't want to spend much time on that. Really don't want to spend much time. So maybe I'm gonna just say I don't even have the location, but I already said that multiple times. So maybe because of that, I should check whether we already visited that module before calling this function, the aforementioned function. Just a second, I can't seem to... Right, because this is where we do all of that. Okay, so this is where we call that. So we check the file exists. This is where we have to check this entire stuff, because this is where we have the location. I'm a huge idiot, right? So, and by doing so, I wouldn't have to rub this huge, this huge if-else, right? I wouldn't need this huge if-else. God damn it, this is actually very interesting. So if I just do that inside out, like I literally don't have to do that. God damn. But I also will have to do some extra work in compile program into ops. Compile program into ops. Right. So when I call this thing, I'll have to... Where is that? Compile. Where's compile file? I didn't see compile file for some reason. Where? Okay, here it is. So I'll have to start the module, right? And then I'll have to finish the module, right? Okay, so that means we'll need to do another big refactoring of like this chunk of code that I was moving around. So yeah, we'll have to do that again. But that should be sort of like the last time we'll have to do that. Before I do that, I want to commit whatever I have already because I don't want to lose the work that we've done. So let me make sure that this entire work compiles, and it can compile itself several times. We might as well even test on tests whether it passes some of the tests. I think it will not pass all of the tests because some of the tests test the include limit. We got rid of the include limit, so the error messages are going to be completely different, but that's fine. So we'll have to update those tests. So let's see how it performs on the tests. So my pi is actually very slow. Okay. So that's a lot of failed tests, that's for sure. Okay, so I didn't expect that many failed tests. Oh, this is because of the debug. Okay, I'm sorry. God damn it. But how can I... I think I know how I can do that. So if I do something like porth, let me find the debug. So essentially, I think we have a global variable called silent. Yeah. So, and if I set something to be silent, I can actually like not print that. And while we're testing things, we actually set silent to true, so it does not interfere with any of the results. So if not silent, right? If not silent, only then we're printing this entire thing, right? You see? Only then we're printing all of that. So another debug. Silent boolean L not. If it's not silent, we're printing this entire thing. So because I kind of want to keep them, they're pretty cool. And another thing in here, compiled. So this is we do that. Silent boolean L not if not. And then we're gonna just close this entire stuff and let me recompile porth. Okay, so that looks fine. And it's funny how it includes relatively fast, but then it takes some time. So what if I say silent? It doesn't print anything anymore and it just recompiled itself. But yeah, so here is the very interesting problem. The flat assembler actually, yeah, prints its own splash, and there is literally no way to tell flat assembler to not do that. There is no flag in flat assembler to shut it up, seriously. So if you take a look at that, it has 4 flags, and believe me, that's all of the flags it has. Right, it doesn't have any more flags. Luckily, FASM is actually open source, so, and it's very small, by the way. It is very small. You can basically hack it to not print this entire thing, but I don't know. Yeah. So the thing I'm trying to work out right now is to like make the cmd echoed command that we use to call external commands to basically redirect to def null on demand, right? So and that way we can shut up FASM when we're testing things. But right now FASM kind of interfere with testing, and that's why I can't get rid of NASM, because NASM actually doesn't say anything during compilation, which is nice. But yeah, it's a separate problem that we can talk about. Okay. All right. Now, so let's do the full testing. Okay, so everything's fine. Okay, so already something with include limit has failed. Right, so include limit exceeded, but instead we've got to do like detected loop, which is actually perfect. And apart from that, only one file has failed. Right, so let's actually update the output for this specific file. Update output, there we go. And let's run it again, because that kind of stopped the whole compilation process, the whole testing. And I want to test everything, not only unit tests, but also examples and Euler problems. So it's taking some time. All right, Euler problems. So all of the examples are fine. Okay, I'm super happy. I didn't break anything. I did a pretty major refactoring of everything, and the only test that broke is the test with include limit, but that was expected, right? Because in include limit we were including ourselves, which is rather interesting. How did it fucking work then? Let me try to compile this thing without the testing. So I'm gonna try to do run tests include. What was that? Something about the limit, right? It was something like self-include. Self-including file. All right, so this is going to be porth compile tests self-including file.porth. Detected a loop. So it started this thing and then it instantly detected a loop. If I try to do that. It's surprisingly quickly detected the loop, which is kind of interesting. But anyway, okay, so I tested everything, so I didn't break anything, and I want to compile whatever I have right now. Right, so what did we do in here? Detect, double, include, and loops. There we go, and I'm going to push that right into the repo. So the only thing we need is like a proper error detecting, but to have a proper error detecting, we need to put the logic of detecting of loops and it double includes inside out yet again. Inside out yet again. So that means we'll have to mess with that huge piece of code that I was missing at the beginning of the stream, which is not particularly pleasant, but that's what I have to do right now. That's what I need to do. And so this is where I start the module. All right. And now I'll have to go and find maybe module finished. Okay. So this is where we sort of finish the module. So this is the entire logic, right? This is the entire logic, this is where I start, this is where I finished, and this is the rest of the things. Right, so we're bringing everything back, right? Let file, so, and the thing here is that I need to truncate a little bit of stuff in here, super quick. Super quick. Super quick. So I think I need to do something like this, right? So there's 4 in here and there's 4 in here, and everything seems to be fine. Everything seems to be fine. Cool. So that is basically that logic. We don't need to have that anymore. So I'm gonna put it in here so we don't lose it. And I'm just gonna bring everything back. Proc. Okay, so we removed all of the like loop detection logic right now. That's precisely what I wanted. And let me try to recompile ourselves just to make sure that that didn't break anything. Everything seems to be fine, which is quite surprising. First try? Question mark? That's very interesting. Okay, so compile prog into ops, right? So this is basically the entry point, right? So this is literally the entry point, and in that specific entry point, so here is the string that we're trying to use. So empty token. Why do we need empty token? Empty. Oh, look at that! I have a dead variable in here. Unused variable. We need to implement a warning about unused variables, because I don't know how many like these unused variables I have throughout the code base, but this is something that we need to have. Right, so I'm gonna put it to do like warning about unused names rather, because they're not necessarily variables. Like the language doesn't have variables. It has memories, it has bindings and stuff like that, but it doesn't have this stuff. So yeah, this thing is unused, so I don't have to worry about it. So this is the file path sister, right? And I don't think I need to care about it in here. So this is where we're gonna put all of that. So this is a file path sister, right? So let me try to recompile the entire thing. It seems to be recompiling, which is nice. And before trying to compile it, this is where we're gonna try to start the module, right? So we're gonna do file path sister module lookup, right? So this is a module lookup, and this is where we have a module, right? So this is where we have a module, and in the module we can essentially check different things. But do we even need to check different things? Because, well, we do need to check it for this specific thing. This is the entry point, and if you have entry point already included into itself, that's a bug. Though, yeah, that should never happen, because this is where you start the whole process. So including should not happen. So we can do something like module null. If it's not equal null, this is straight up a bug, like at this specific place. So this is assertion failed. So I'm gonna do here eputs assertion failed. The entry point module should not be included at this point. The entry module should not be included at this point. If something like that happened, that's a bug within the compiler, because that's kind of sus. That is straight up sus. So that means we don't really care about the module in here. So that means I can get rid of this binding and sort of like merge this entire stuff like that, right? So file path module, if it's that, we're gonna do that. Then we probably want to start the module, right? So it's going to be file path sister module start. We're starting the module. We're starting the module. So this is where we get the module. I can probably do it like this, module in here. Maybe even something like that. Right, I start the module, then I compile this thing, and then within the module, I'm going to do module. So, but it makes it kind of unclear, like where the module coming from. So that maybe that's how I'm gonna do that. Module. Do I have any other things? Do I have module start and I have module lookup, right? And I say okay, module finished pointer plus true boolean. There we go. Okay. Which actually makes it very easy to get rid of this thing and just do something like swap. Yeah, that's pretty cool. I really like that, I think. Yeah, so this is where you start the module, then you do this thing, and then you choose swap. So it's kind of cool that LED bindings are cool, but they also synergize with the original fourth style of development, right? So they kind of help you to come up with the fourth style. So this is actually super cool. Like, I don't have to keep track of the stack in the comments anymore. I can just like do first dumb layout of my logic with LED bindings, and then from the inside out I can compress LED binding back into the fourth style of programming. This is so interesting. Holy fuck. Right. Huh. Mr. Karagoz saying uwu uwu. Thank you so much for 3 months of Twitch Prime subscription. Thank you, thank you, thank you. And welcome to our epic uwu clap. Anyway, so I'm part of the clap. Hello, Jay. What's up? Let's go. So this is, I really like that. So I really like how the fourth style of programming and the new LED bindings do not conflict with each other. So they sort of like synergize each other. It's really cool. All right, so what do we have in here? I'm going to do module start, and this thing is not equal because it's a pointer, right? So everything is typed in here. Alrighty, so, and we kind of have to repeat this code in all of the places where we call compile file into ops during the include, like right here. Alright, so there's only one place where we do that. Okay, that's fine. Nice. So there is like dupe. There is so much dupe in here. It's insane. Dupe. And then it gets consumed by this thing. So we might as well. Okay. So this is where we prepare the file name, right? This is where I prepare. And it goes through several stages of like trying different things until we settle on something. And this is where we're gonna do it like that. Include file path sister, right? So include file path sister. And this is where we're gonna do it like that. So module lookup include file path sister. Include file path sister. So, and in here, this is a module. And if so we can have several situations in here. So here's the module, and the module could be null, right? And if it is null, right, if the module is null, that means we need to include the entire thing, right? That means we need to include the entire thing. But that means also that we have to start a new module. Include file path module start. Module start, so that gives us that. Then we include the module, and then we do true swap module finished pointer plus boolean, like this. So this is one situation. The second situation is when module does exist, but it's not finished, or rather maybe it is finished. Pointer plus boolean, and it is finished. In that case, we want to ignore that module, right? We want to ignore it, and I think I do have a logic for that in here. Yeah, we can just do silent ignoring. Yeah. Okay, so I really don't like how huge of a name this is. Include file path. Let's just call it include path without sister. I don't think it's gonna cause too much confusion. I don't think so. All right, so, and otherwise, if it's not finished yet, that means we found a loop. Right, and this is where we want to say detected a loop, right? So this is where we want to say that. So, all right. So include that, then silent, detected a loop, and this is where we finish all that. Okay, so that's fine. That is pretty straightforward. Okay, so let's try to compile this entire thing. And first try it. Actually, first try it. I'm really surprised. What the fuck? So if I try to compile our thing in here, it should say detected loop. It, in fact, a detected loop. So, cool. But there is a huge difference between previous situation. We have the location of the token to report about the detected loop. Right, so now we can do the following thing. We can take a token, token location, pointer plus, input lock, error, detected loop puts, and that should be it. Right, so this is like initial implementation. Let's see how it goes. This is the initial implementation and detected loop, and it talks about this thing. So that's pretty cool. It detected loop in here. But we can try to also keep track of where a particular thing was already included, if you know what I mean. Can we try to do that? Can we try to do that? I think we can try to do that. So let me see. We can extend the module structure. Size of module already was there. Okay, so what if we extend and add module location? So essentially the original, the first location maybe. The first location maybe. Though I really like the idea of the stack of the parents, you know? It's kind of cool idea, but I just don't want to spend too much time on that right now, at least. But maybe I have to. Okay, let's try the idea of actually storing the location of where this entire thing was included. Printing the wrong path in the ignoring. You're wasting my time. Why are you wasting my time? Oh yeah, I do. Okay, so you're not wasting my time. All right. Thank you. Thank you. All right. Though it's a debug output, it doesn't matter. It's going to be removed anyway, so... okay, cool. So ignoring... nice. When we start the module, we... parse.parse. Module start. So this is the full path. We might as well try to accept the location. But do we need to? Maybe not. And also, when you start something, when you compile the entry point, it doesn't really have the original location. So that's kind of the main problem in here. It doesn't have the original location. So it's not gonna properly, you know, report anything. Yeah, how, like, what's the location of the entry point? What's the location of the entry point? This is a really hard problem. Like, how do you properly report this thing? How do you properly do that? Because the entry module doesn't have an include location because it was not included from anywhere. It was included from the command line, right? It was included from the command line, and we cannot have the location of command line because, you know, location is, you know, file path, row, and column within the file. So that's really interesting. That's really interesting. How do we report all of that? Maybe for now I'm not gonna bother too much, right? Because like it's really unclear yet, and the entire sort of module system is not really finalized yet because the entire thing is pretty much hack, right? I don't plan to just, you know, include the contents of other files. I want to have like modules and everything. So maybe in the future all of that is going to be gone, and maybe I shouldn't spend too much time, but we'll see. So detected, okay, loop. I'm going to put it to do. Report more information on detected loop, right? Something like that. And another one is going to be full path. So this is going to be the full path. And I want to put another to do here. Use the full absolute, even though it's like a, you know, repetition, a full absolute path to the module. Because it's supposed to be unique, but not necessarily, right? because you can kind of still like trick the entire system with symlinks and stuff like that, right? So it just like depends on what we're using as the ID of the file that we already included. What's the ID? I think the full file path is pretty good idea. Though the question is, what? I've just got a crazy idea actually. What if we associate like a module name with each individual file? What if we'll tell to the user, you define the ID for the module, and we use that ID as the unique ID of that module? So that way we don't have to mess with the full paths and not full paths and stuff like that. Right. That's pretty cool, isn't it? And of course, like to make it super unique, you would do something like, I don't know, like sogin.org/port or whatever. Something like that. So it's sort of like a module ID. That's a very interesting thing. So you know what? I'm gonna think about that. I'm gonna think about that, because then if we have something like that, this feature will more or less seamlessly blend into proper modules in the future. Yeah, package. Package org sogin port, right? Something like that. Yeah. Perfect. Because like the sole purpose of this entire thing is to have a unique ID for the module that we're including, so we don't include them twice, right? Something like that. We could use paths as the unique IDs, but that creates like a whole level of complication, right? Whole level of complication, which I don't really want to go into. So it would be nice to have some sort of ID. Hash is also pretty annoying to compute. So why not just let the user decide what's the unique ID, right? And the user may define the uniqueness of the ID by maybe prefixing their host name or something like that, or yeah. Okay, can't you just use a hash of the content file? What did I just say? The comprehension of the chat is just like astonishing. Anyway, so full absolute path. Okay, so more reliable ID of the file we are including. Okay. So, and I'll think about that a little bit later. So there's a bunch of to-dos in here, and let me start the testing. Why stop at one hash? Make each file an NFT leaving. By the way, you actually reminded me, there was a language where basically each individual function had a hash of its implementation, right? So who remembers what I'm talking about? So essentially you have a function and it like uses the implementation of the function as a unique ID of that function, and then it stores that function in some sort of like database. Unison, right? So yeah, something like that would be like, can we also use like a blockchain for Unison? Right. So Unison must use some sort of a blockchain for all of these functions, and to define the ownership of the function. Yes, perfect. So basically functions NFTs, and you can sell and buy. Holy fucking shit. Oh my god, this is so cool. I will implement that. Unison, but with NFTs for functions. Holy shit, somebody needs to do that. Yeah, so Unison programming language. Left pad NFT, yes, perfect. Holy shit. Left pad NFT. So whoever owns left pad, they're gonna be the, you know, the richest person on planet Earth. Yes. It's a whole new way to monetize programming, I tell you, this is amazing. All right. So we need to do these kind of things. So we need to update the output. Update output. There we go. Find file at point. So that's ooh. I think I did a fucky wacky and possibly oopsie doopsie. So because here, yeah, I supposed to use the standard error, right? So let me recompile porth. Okay. Cool. Compile two modules. So maybe I'll need to. So let me also recompile it one more time, just in case. And let's update the entire stuff. Find file at point. Perfect. And let's start the whole testing process. Imagine instead of fork system, you get a buy NFT of that code base. That would be actually kind of cool. Right. Okay, so everything seems to be okie dokie, a karaoke. Though we're only testing the detection of the loop, but that's fine, I guess. That's totally fine. Let me do a committee. Report the location of the include loop, sort of, kind of. And let me push that right into the repo. Let me push that right into the repo. Okay, so one of the reasons why I wanted to actually implement include once is because I wanted to start separating the standard library into several files. Right. So because right now the standard library is a little bit of a mess. I don't speak English, I'm sorry. Right. So we have a lot of Linux specific things as well as POSIX things, right, which are more cross-platform than Linux things. And we also have things that are very specific to Porth, right? So we have like these three things mixed up. And I want to kind of separate them. I want to separate what's Linux specific, then I want to separate what's POSIX, which is more or less portable, right? Which is more portable than you think. And then basically separate what's Porth, right? So additional things that Porth adds on top of these like sort of standards, if you can, you know, call them that way. The entire structure is going to look like this, right? So we're going to have some sort of a module which is Linux, right? And then we're going to have a module POSIX, right? POSIX. Module POSIX. And POSIX depends on Linux, right? So there we go. Then in the future, we can maybe add more POSIX-like separating systems like BSDs and whatnot. And this is going to be a separate module, separate file, and the POSIX module will reuse like different, like, you know, underlying implementation and stuff like that. And Porth, the standard library of Porth, let's just call it STD, right? STD. It can be implemented on top of POSIX, or maybe in the future, we also gonna have Win Win32, right? And the std thing can be also implemented on top of Win32. And by the way, is Win32 deprecated, right? So why does it still have like 32 in its name when it's like all about 64 bits these days? I'm not quite sure, but anyway. So, and maybe when we start compiling this entire thing for WebAssembly, we're gonna also have a WASI, right? So WebAssembly System Interface. By the way, for anyone who's always wondered, what the hell is WASI? Right, you can roughly say that WASI is on the same level of API as POSIX or Win32. Roughly, not really, like all of the things are kind of blurry, the edges between those things, but WASI is kind of like a competitor to POSIX. Right, and in fact WASI even kind of looks like POSIX, but it's slightly different. So, and that's what you usually do if you want to compete with other API. You make it similar to that API, but slightly different. So if you depend on that thing, you're not compatible with the other things. And I have a conspiracy theory, by the way. I had a conspiracy theory that WASI is somebody's attempt, some like big web company attempt to actually break the status quo of POSIX. Right. So essentially, when WebAssembly takes off and when it becomes more popular on actually like native on the like executing outside of the browser, WASI may actually start competing with POSIX, right? And maybe it will outcompete POSIX at some point. That's what it feels like. The first time I looked into WASI, it felt like somebody's attempt to actually like overthrow POSIX. But it might be just a conspiracy theory, but I don't know. So yeah, and we may have something like this. But here's an interesting thing. On top of that, we also have things that are universal for like every platform, and they work for every platform. Things like null, right? Null is like probably going to be used by all of those things. Or for instance, size of U64 or true false, like very universal things like std and std is actually platform dependent, but things like that. So, and for things like that, I think we're going to have something like core, right? So all of them are going to go into core, and all of these modules will probably include core, right? Because all of them will need null, all of them will need true, all of them will need false. It's sort of like a prelude of this entire thing. And because of that, you're including like a lot of files several times, and that's why I needed to include once, because once I start separating things like that, as you can see, I'm starting to have a mess, and I don't want to include the same things twice, right? And that's precisely why I needed all of that. Does it make sense? Hopefully. Win32 is the 32-bit API, Win64 is the 64-bit on API, WoW64 is the 32-bit on 64-bit compatibility layer. Oh, finally! Somebody explain me what is WoW64. Thank you so much. Like, I heard about WoW64, but I never bothered to look into it because I'm a Linux person, I don't give a shit. So, yeah, thank you so much. Like, now I know. So they're trying to have compatibility layers between each other. Windows on Windows 64, I think. Oh, okay. That's funny. All right, so yeah, okay. Man, like every time I look into Win API, it like looks like a huge mass of compatibility layers and like things on top of each other, just like to keep the old things working. It's just like insane. Holy fuck. But I guess there's a lot of entities that pay a lot of money to Microsoft to actually do that, to maintain their old software. So, so, and to start like separating the standard library like this, that's why I edited code. Right. Okay, good. So I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Thank you for all of the donations, for all of the subscriptions. We have a QRDCV, with 2 months of tier 1 subscription. I'm sorry that I actually missed it. It was 5 minutes ago. Thank you, thank you, thank you. And yeah, I guess I gotta go. Hope today's session was interesting. We did a little bit of a graph traversal in Porth. Isn't that epic? Graph traversal in Porth. That's actually pretty epic. Right. People saying maybe soon you'll be able to compete with AOC in Porth. I can traverse graph in Porth. I can compile languages in Porth. Porth is already kind of usable language. I can do a lot of things in Porth. It's just like I don't want to compete in AOC. Anyway, thanks everyone for watching. I gotta go. I'm gonna eat something. Love you all. Mwah.